It's what? A sequence of numbers? Yeah. If I said my heart rate was 92 beats per minute, or or I drove 57 miles per hour. What do you know about a rate? What is the first thing? The first time I said beats per minute, I gave you 2 units. Beats on the top, minutes on the bottom. Miles on the top, hours on the bottom. So rates have different units. So when we talk about a rate of change, the reason that we say rate of change and slope are the same, they are. Rate of change though deals with real world problems. So we're talking about different units. Whereas when we talk about slope, we're just talking about units on units on a coordinate grid or something. So the reason they're the same is because they calculate the same thing. It's just called a rate of change because it's a real world example. So it says the graph shows Raquel's distance from home as she drives. So notice that the x-axis, I don't know if you guys can see that down there. The x-axis is in time, and the y-axis is distance. Time in hours, distance in miles. And remember, we always put y over x. That's why it becomes miles per hour when we calculate it. So it says determine the slope of the relationship using the slope formula and the 2 points. Someone remind me from yesterday what the slope formula is. That's slope intercept form of a line, and we didn't do that yesterday, but good. I love that. You know that. Keep that in your brain.
y2 minus y1 over x2 minus x1.
Perfect. Nice job, Dominic. So where do we get those x1, x2s, y1s, y2s? Where do those come from? Yeah, we take our ordered pairs and what do we do to them? Yeah, but what do we do with the ordered pairs before we subtract? Yeah, you should label them. You should label it x1, y1, right? X sub 1, y sub 1, x sub 2, y sub 2. Why is it good to label those? Why is that a good idea? Yeah, so you don't mix them up. And then remember, when we use that formula, I always just draw a fraction bar. And what do I put on my fraction bar? Do you guys remember yesterday I said I always do it this way? Awesome. Parenthesis minus parenthesis in the numerator, parenthesis minus parenthesis in the denominator. Because if I have negatives, I'm less likely to make a mistake, right? When I have negative numbers, I'm less likely to mess that up. So y2 is a little bit bigger than what my parenthesis is going to allow for. Y2 is 116, and y1 is 348. X2 is 2, and X1 is 6. So calculators, get your calculators out. Someone grab a calculator if you're close to it. You guys should, like, from this point on, you're going to want calculators. I would say pretty much every day. Someone tell me what 116 minus 348 is. Negative 232. Good job. Thank you. What is 2 minus 6? It's negative 4. A negative divided by a negative is a positive. So when we simplify this, what is 232 divided by 4? 58. What is my unit in the top? Miles over 1 hour. 58 miles in 1 hour, or 58 miles per hour. So that's the slope of this linear relationship. What are the units? Well, I already wrote that down. 58 miles. I'm going to write it as per hour. And what does this slope represent? So this is the distance from home as she drives to college. So this is her home, and this is her college. Yeah, she's getting closer to her college. Okay. What else? Yeah, It represents her speed. Her speed, the average, not of, over how many hours, how far away does she live from, how far away is her college from home? Yeah. So it's her speed. It's the average over 8 hours. Okay. It's the average over 8 hours. For those of you that I gave filled out notes to yesterday, you have this. This is still a part of your packet because I copied everything, just so you know. So I'm going to slide up to slope as a rate of change. Slope as a rate of change. So when I use this little symbol right here, this is a physics symbol or a chemistry symbol. It just stands for change. Have you guys used that in any of your science classes yet? Yeah? Okay. So it's just delta. It's the Greek delta, and it just means change. So when we talk about the change in the dependent variable is the y, and the change in the independent variable, that's the change in the x. Okay? Change in the dependent over the change in the independent. I'm going to have them back here. So let's look at Hachi. He's driving a car at a constant speed on this New York State Thruway. He notices that after driving for an hour, he had 12 gallons of gas left. And then after driving for a total of 3 hours, he had 8 gallons left. Assume in this problem that there's a linear relationship between the amount of gas left and the time that he's been driving. Let's first off find the two ordered pairs in the word problem. What are the two ordered pairs in our word problem? We should be on page 23 in our packet. Yeah, our first ordered pair is this right here. 1, 12. This is time, hours, and our x-axis is always like time. And this is gallons. What is our other ordered pair? 3 and 8. Okay. So those are our two ordered pairs. It says express it as two ordered pairs, 1, 12, 3, 8. Calculate the slope of the line that's connected to these 2 points. Include your units. So I'm going to just label this x sub 1, y sub 1, x sub 2, y sub 2. And when I do the slope formula, when I use that, y2 minus y sub 1 over x sub 2 minus x sub 1, what am I plugging in for those parentheses? Jerry, what is y2 or y sub 2? Yeah, 8. Good job. And what is y sub 1? Sophia. God bless you. Good job, 12. God bless you up front. What is x sub 2, Carter? And what is x sub 1? Carly. Good job. So 8 minus 12 is -4. 3 minus 1 is, so my slope, when I reduce it, I can divide both of these by 2, is -2 over 1. It says include your units. So -2 gallons for every 1 hour that I drive. What does that mean, -2 gallons?
Every hour that you drive, you use 2 gallons.
Yeah, you're using it, right? The gas tank, the amount of gas in your tank is going down. That's why it's negative. So every hour that you drive, you use 2 gallons of gas. So how long after he started driving will he run out of gas, assuming that this rate that we calculate does not change? So I just made a table. I just wrote it like this: hours and gallons. Because I have to kind of like, I don't know, I just have to visualize it, right? And I know that if I have been driving for 3 hours, I have 8 gallons. That was our last ordered pair. And what's happening to our gallons every hour? Yeah, our gallons are going down by 2 for every +1 hour. So what's my next set of points going to be, or my next coordinate? Well, 3 + 1 is, and 8 - 2 is, okay. And then I follow that same pattern. I know that if I drive for another hour, my gallons of gas is going to go down 2. So down 2 gallons +1 hour. So 4 + 1 is 5 hours. And I'm down to how many gallons? 4, 6 - 2 is 4. Yeah, why is that there? So it should be a 4. Same thing. 6 becomes, and 7 becomes what? So when am I going to run out of gas? Yeah, after driving for 7 hours. You have 0 gas left. 0 gas left in the tank. So if you didn't stop before then and your low fuel light didn't come on, you might be in some trouble. So flip over to the back. We're going to do question number 4. All right, exercise 4. Over the time interval given, calculate the rate of change for each variable. Include the units in your answer. So we have to kind of glean the ordered pairs from the word problem. So at 3 weeks old, a corn plant is 4 inches tall, and at 15 weeks old, it's 46 inches tall. So what are my ordered pairs? Yeah, so 3 weeks and 4 inches. And what's my other ordered pair? 15 weeks and 46 inches. So x sub 1, y sub 1, x sub 2, y sub 2. So I know that my slope formula says that I take y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So what number am I plugging in for y sub 2? 46. Y sub 1? Anyone? 4. X sub 2. X sub 1. So 46 minus 4 is 15 minus 3 is, can we reduce that? What do you want to divide by? Yeah, let's divide by 6. They're both even. You could start dividing by 2, but they're also both divisible by 6. 42 divided by 6 is 7. 12 divided by 6 is 2. Remember the change in y, that's my y coordinate, inches. So the plant grows 7 inches every what? Every 2 weeks. It grows 7 inches every 2 weeks. Braden, are you filling out your notes? Okay, can you pick up your pencil and do that? After driving for 4 hours, Tom is 82 miles from home. After driving for 7 hours, Tom is 244 miles from home. Is Tom getting closer to home or farther away? He's getting farther away. Good job. So that means this is increasing. So what are my ordered pairs here? 4 hours, 82 miles. Okay, and the second one? Good job. So 4 hours, 82 miles, 7 hours, 244 miles. X sub 1, Y sub 1, X sub 2, Y sub 2. So when I calculate my slope or my rate of change, I do parenthesis minus parenthesis over parenthesis minus parenthesis. So Y sub 2 is what value? 244 minus what is Y sub 1? Over what is X sub 2? Minus X sub 1? 244 minus 82. $162. And 7 minus 4. Okay. Can I reduce that? Yeah, I can. I can divide by 3. 162 divided by 3 is 54. So 54 miles in 1 hour. Again, when I gave you guys your filled out notes yesterday, this was part of the packet. This was in there. Okay. All right. So I'm going to freeze that. So your homework, page 24, questions 1 and 2, and page 25, 3, 4, and 5. You have 5 questions. 5 questions. And we're going to do a journal entry together. We're going to do a journal entry. Jerry left it in here. Oh, no, not Jerry. Sorry. Samuel left it in here. Go back there and look. I'm pretty sure that's Samuel's binder. Dominic, will you look on that stool? Doesn't that say Samuel Newkirk inside on the schedule? Yeah.
Jerry.
Oh, does it say Jerry? Thank you. I thought it was Sam. There you go. So you still have filled out copies. Okay. Sorry about that, Jerry. Okay. So journal. So this is our unit 2, lesson 2.3. I will tell you this one does not have the I can statement on it. You're gonna have to write your own. Oh, you're gonna have to write your own Ryland's got your guys' stack. 1, 2, 3, 4. 4. Okay. Okay. So I'm going to fold this in half so it makes like a little book. And I'm going to give you guys a minute to write down your I can statement on the front of it. I'm going to give you a minute to write down your I can statement. And I'm going to project it so you don't even have to look for it. So this is 2.3a. 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 Do you guys see which one I need you to write down? I'm trying to make it as big and in the middle of the page as possible. So you're going to write that down. I would put it right underneath the rate of change in slope. 2.3a. I can calculate and interpret the rate of change and the slope given a table of values, two ordered pairs, a graph, or a verbal description. So yesterday we focused mainly on table of values, two ordered pairs, and a graph. Today's exercise was really about that verbal description. Notice that from a verbal description, that's where we get our ordered pairs. When we're solving with a verbal description, we actually get our ordered pairs from that, okay? I can calculate and interpret the rate of change and the slope given a table of values, two ordered pairs, no, just 2.3a. Just 2.3a. I can calculate and interpret the rate of change and the slope given a table of values, two ordered pairs, a graph, and a verbal description. I'm going to give you another minute to get those written down, and then we're going to open up the inside and I'll put those back up. All right, we're going to go to the inside. I'll project those ICANs again. Where can you find your ICANN statement? The bright pink paper that I gave you at the beginning, right? Your unit 2 should be bright pink. Unit 2 should be bright pink. So we're going to talk about rate of change. I'm going to shut off that front light. We're going to fill in all of these, this graphic organizer. I need you to stay with me. You're going to come and stand back by me, okay? You're not putting your head down. So, rate of change. What did we say the rate of change was? The change in what over the change in what? The change in what? Did you say X over Y? Oh, rise over run? Yeah. It's the change in the Y. Sorry, it's the change in the Y over the change in X. It's how one, so I'm going to write it like this. I need a thicker. I have to raise it up so I'm writing on a can or like a pencil holder and it's flimsy. There we go. So what does rate of change mean? It is how one variable changes in relation to the other variable. And then in parentheses, I'm going to write different. We said that they have different what? Miles per hour, beats per minute. Thank you. Different units. How one variable changes in relation to the other variable. So I'm going to give some examples. And I'm going to write miles per hour. What's another one? We did gallons of gas per hour we drove. And we could also do something like, if we're talking about heart rates, we could do beats per minute. Beats per minute. So Kian mentioned this today, and I think he mentioned it yesterday. This is our lesson for Thursday. We're going to talk about the equation that we use to represent slope. Ken, do you want to say what that linear function is again? Yeah, y equals m times x plus b. Raise your hand if you remember that, if you remember seeing that. It's okay if you don't. All right. Yeah, so y equals mx plus b, where m stands for the slope and b is the y-intercept. After I say that, I hear some people saying, oh yeah, I need to move that little pencil out of the way. It's in our line of sight. So m is your slope and b is your y-intercept. So an example would be y equals 2/3 x plus 4. This tells me that I rise 2 and I run 3. This tells me that I start at 4 on the y-axis. I start at 4 on the y-axis. When we look at a table, of values, do you guys remember what we're looking for to find the slope? Well, remember that our slope equals our change. I'm going to use that delta symbol, our change in y over our change in x. So let's just make a table of values. Doesn't have to be fancy. And I'm just going to use -4, -2, 0, 2. And let's use -2, -1, 1. Sorry, 0 and 1. I'm going to put 4 and 2 up here. So in my table, I have on the x-axis, -4, -2, 0, 2, 4. And on the y, I have -2, -1, 0, 1, 2. So when I talk about this, remember I'm talking about my change in y. What happened on my y side? I added 1. Change in y. Each time I'm going down, I'm adding 1. I'm increasing by 1. What's happening on my x-axis? We're adding 2 each time. So my slope is going to equal my change in y over my change in x. And that's how we do that from a table. You guys feel okay about that? All right, I'm going to write around this little circle. What did we say slope was? It's the steepness or slant. Steepness or slant of a line. Do you guys remember that? That says steepness or slant. I don't know if I can make that any closer. I just wrote steepness or slant. I've got this scanned so we can post it. So on this side, we're going to focus on what does slope tell us? And on this side, we're going to do, how do I find it? How do I find it? So what does it tell us? How do I find it? I'm going to give you a second, and I'm going to slide over to the box that says direction and steepness. Does anyone remember the 4 directions of our slope? What are they, Ken? Negative. What else? Yep. Not no solution, but 0 slope, or what? Undefined. So I'm going to draw 4. This is scanned. This is scanned as well. I'm going to draw 4 little XY charts. XY, like coordinate grids. XY, XY, XY. So let's start off with positive slope. So positive slope looks like as X gets bigger, what's happening to the Y value? Y is getting bigger. We say that it's increasing. Y is increasing. If we have negative slope, so the one below it, if we have negative slope, what's happening to our Y value? Yeah, it's decreasing. It slants down. It's decreasing. Sometimes we have special lines that don't have any slope at all. Do you guys remember what kind of line that is that has 0 slope? It's horizontal. Horizontal line. Looks like this. And it has 0 slope because it never rises. 0 slope. And then our last direction that we learned yesterday was undefined, which is what kind of a line? A vertical line. So we could have a vertical line. Means our slope is undefined. And it looks like this. That's a vertical line. So I'm going to zoom out for a second so you can see those last 3 that the last 2 that I did, horizontal and vertical. I'm going to wait a second and then I'll slide it up if you need to see the positive and the negative. Okay, let's go to steepness. Let's talk about steepness. So I'm just going to draw 3 XY coordinates here. 1, 2, and 3. Because I want to put a little bit more words in there. So the first one that we're going to do is going to be hardly slanted at all. This is less steep. And your slope is positive, but it's less than 1. Your slope is positive, but it's less than 1. Next one that I'm going to do is going to be like maybe this. This is more steep than the one above it. Still has slope that's positive. It's probably pretty much equal to 1. I'd say that's a slope that's equal to 1. And then we said anything larger than 1 has a much steeper slope, right? A much greater slope. So we'll do one that's very steep. So a positive line that's very steep, that's something like this, right? This is very steep. Like if you were climbing up that, if you think about being a hiker, that'd be almost impossible to climb up, right? So here's your slope. It's still positive, but this is definitely greater than the number 1. Greater than the number 1. Okay, let's sketch a graph really fast. Let's sketch a graph of a line that has a slope equal to -2/3. How are we going to do that? Well, I'm just going to do 1, 2, 3, 4, 4 above, like 4 on each. I'm just putting 4 little hash marks on each of my X and Y axes. It doesn't say where I have to begin. So I'm going to begin on I'm going to start over here at -4 on my X axis. Just going to plot a point right there. This is just an example. So because it's negative, and when we count slope on a graph, we do rise over run. Because it's negative, what does that mean? It means my slope is negative, but am I going to go up to get to the next point, or am I going to go down? I'm going to go down 2 units. I'm going to go down 2 units, and then how much am I going to run to the right? 3 right. So if I go down 2 units, 1, 2, that's going to put me right here at -4, -2. But then I have to run 3 units to the right. 1, 2, 3. So I actually end up right here at the point -1, -2. We started at the ordered pair -4, 0. That's an example of how you could count slope. What do we need to do with those once we get our 2 points? We're making a what? Yeah, connect them with a line, right? So connect your dots. Hopefully a little better than I did because I missed it, but almost done. I know I told you I'd try to give you about 40 minutes. We're going to get about 30 minutes, I think, to work on our test corrections. I want to talk about what the ratio is, how we find it, and then slope between 2 points. Okay. So ratio, we set it up. Remember that our slope is either our change in y over our change in x. We count it as rise over run. We also say it's the change in y over the change in x. And our rise over run is our vertical over our horizontal. Vertical over horizontal. Okay. You guys know how to do the slope between 2 points. What is it? How do I find the slope between 2 points? What's the formula? We call it the slope formula. Yeah, y2 minus y1 over. Okay, let's give an example. Someone give me 2 points. 2 ordered pairs. Anyone? 8, 3. And what else? 2, 7. I love it. Is this going to have positive slope or negative slope? Negative. It's going to have negative. So x1 sub 1, y sub 1, x sub 2, y sub 2. So y sub 2, parenthesis minus parenthesis over parenthesis minus parenthesis. 7 minus 3 over 2 minus 8. What is 7 minus 3? It's 4. And 2 minus 8 is? Does this reduce? To what? Yeah, I'm going to write it as negative 2 over 3, which is so funny because that was what our slope in our graph was. Crazy. Okay, get the glue sticks out. You filled all this stuff out. Will you turn the lights on for me, anyone? Please. You gonna pass them out? You're awesome. Glue sticks out, glue them up.